Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of equation of a plane. So as per the problem, the plane with equation intersects the y and z axes at the points A and B respectively. Determine the equation of the line that contains these 2 points. So we are given equation of a plane in vector form, and this plane intersects the y-axis at A and z-axis at point B. So the first step is to find the coordinates of points A and B. So let's start with point A. A point on y-axis will have x and z coordinates equal to 0. So that's the first thing we need to understand about this problem. Let's assume the coordinates of point A are 0, y, 0. So we have to find the y coordinate of point A. This point A will also lie on the plane because at point A, the plane and the y-axis intersect. So we can use this point for position vector r in the given equation of the plane. Next, we can break up this vector equation into parametric equations. So let's start by writing the x equation, and for that we'll use the x components in these vectors. And we'll multiply the components of the direction vectors by the parameters m and n. So the x equation is now we can write the y equation. So I use the y components of these vectors. And next we can write the z equation by using the z components of these vectors. Next, we have to solve two of these equations to find the value of m and n that correspond to point A, and then we'll use those m and n values to find the value of y. So we'll use the first and the third equation to find the value of m and n. We can rewrite these equations. These two equations make a linear system, so we can use substitution or elimination method to solve this linear system. We can use substitution method. We can isolate m from the first equation by moving the 1 and the n term to the left side of the equation. So we get now we can do the substitution for m in the second equation. We can replace m with minus 1 minus n. Now this equation has only n variable, so we can solve for n. We can distribute 5 into the parentheses. Now we can combine like terms. Next, we can add 2n to both sides. Now we can divide both sides by 2. I get n equals -1. Next, we can sub in this value of n in this equation here to find the value of m. -1 minus -1 is equal to 0. So m is equal to 0. Now we can sub in these n and m values in this equation here to find the value of y. I get y equals 3. That means point A is 0, 3, 0. Next, we have to find point B. So we have to find the point of intersection with the z-axis. A point on z-axis will have x and y components equal to 0. Let's assume the point of intersection is 0, 0, z. This point will also lie on the plane, so we can use this point for position vector r in the vector equation of the plane. Next, we can break up this vector equation into parametric equations. Let's start with the x equation, and for that we'll use the x components of these vectors. And we multiply the components of the direction vectors with m and n. Now we can write the y equation using the y components. And next we can write the z equation using the z components. So these are the parametric equations. Now we have to find the value of m and n associated with the point B, and then use those values of m and n to find the value of z. So we'll use the first two equations to find the value of m and n. So these two equations make up a linear system, and in this case we can use the substitution method to solve this linear system. For point A, we isolated variable m from the first equation and we got. Now we can do the substitution for m in the second equation. Now we have to solve for n. We can distribute 2 into the parentheses. I get n equals 0. Next we have to find the value of m, so we should sub in n as 0 in this m equation. I get m equals -1. Now we can sub in these n and m values in the z equation, this one here, to find the value of z. I get z equals -2. That means point B is 0, 0, -2. Next, we have to use points A and B to find the equation of the line that contains these 2 points, and we can use the vector equation of a line. So let's start by writing the general equation of a line in vector form. In this equation, vector r is position vector of an unknown point that lies on the line. Vector r naught represents position vector of a known point that lies on the line. T is a parameter and it can be any real number, and m is the direction vector of the line. For position vector r naught, we can use any known point that lies on this line. I will use point A. Next, we have to find the direction vector of the line. For that, we can subtract position vectors of any two known points that lie on this line. So I will use points A and B. We can also do OB minus OA, but I am doing OA minus OB. So we can use point A for position vector OA, and B for position vector OB. Now we can subtract these vectors. So we should subtract their x, y, and z components. So this is the direction vector of the line. Now we can write the equation of the line. So this is the vector equation of the line that contains points A and B. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.